Hey guys, welcome back to the next video. In this video, we're going to understand more about SSL. So, we're going to talk about two interesting topics over here. So, one is about your single key file and multiple key files or a key database. Now, as part of this particular JBoss and HTTP, we are going to secure both the JBoss and HTTP as well, as promised by me. So to cover those two items, right, first we need to understand what kind of a key formats these supports, and then what is the procedure of getting a key, what are the different types of keys available. All right, that's first thing I want to talk to you about. The first, on the left side, let's talk about that because we are going to use Apache HTTP server, which will be using the single key file format. So I was just having a sip of my green tea. Just make sure that you have something with you when listening, or else you'll fall asleep. So here is you have the private key. So private key is the first thing which we generate as part of the key generation process. And then there are two routes here. Yeah. So the first route is like you can go for a self-signing route, as in like I am saying that I'm a good guy, but do you trust that? You don't trust it. But if someone else that you know says that I'm a good guy, you trust me then, because someone is authorizing, and that someone is known for you, and they have earned your trust. So if someone else who has earned your trust is saying I'm a good guy, then obviously you will trust and you will think that I'm a good guy because I have done something to them to prove that I'm a good guy, and then they are referring you to me, right? The same thing goes as a self-signed certificate where I'm talking about myself that I'm good. But then there is another way, it's called CS signed certificate, a certifying authority signed certificate, where you have like very less number of certifying authority around the world, and they certify my website saying that this guy is a good guy. I have checked all the things which is necessary for me to check and verify, and he seems to be clean. And they only certify me. Previously, they used to certify for 2 years, but then I guess the trust issue is fading away little by little. So now they are only trusting for a year, and then we have to go and ask them for another. I'm still good, and then please trust me again. So it's happening year by year now, and then I think it's gonna go 3 months by 3 months very soon. But then there are tools now which is automated to do the certificate renewals. There is this management of all your certificates which automatically gets signed, and then you can just blacklist and whitelist the certificates. So that those things are there. We'll come to that later. But there is this two routes. I'm not sure if I'm covering that. Just bear with me. Yeah, so this is over here. Sorry, I think I'm talking about this without presenting this. So there is two routes over here, as you can see. One is when you create the private key, you can go through the self-signing route, where you say that you're a good guy, and you give all your details, your expiry date. Expiry date here can be irrelevant. And then you will get a CRT file. So certificate file. CRT is nothing but certificate. Sometimes it is called a CER file also. That is also certificate. Okay. CRT and CER. Now, on the other hand, if I'm going to a third party, what is the advantage of it? First thing, I need to pay them. Second thing is that they will validate me whether I'm doing any kind of a wrong activity or whatever I'm doing is correct. So they have this validation. Now, who are these third party? I'll tell you the next one in the next bit of minutes. So these verify my items, and then I send them the third party, and then they create a CSR. This arrow should not exist, actually. Just forget that you saw that arrow. But this is how it is. So there is no direct way of getting to the CRT. You either go by the self-signing route or you go by the third party route. If you're going by the third party route, you have to generate a CSR. Okay, there's a command to generate a CSR in terms of your single key file store, as I told you earlier. If you are doing with the key manager or a key database, it will automatically generate it. I'll come to what is that little in some time. So you have two routes over here. These are the only two routes, and there is something called a demo certificate that's around it, but then it's not used much actually. Demo certificates are not trusted by most of the browsers, so it's not in use. So going back to the previous diagram, so the first one, the first one we are talking about is the private key, and then CSR and then CRT, right? So the private key is what is created first, and then there's option that whether you want a CSR or not, and then you get a CRT from in the end. Either you go by the self-signing route or by the third-party route. So who uses this? It's your load balancer, Netscaler, another load balancer uses it. And then you have the HTTP server, like our Apache HTTP server uses single file based certificates. Now, what is the advantage of using single file certificate? No complications, all right? So there's no passwords here to protect these key files. So it's basically a single file will be there, which is private key, and single file will be there, which is certificate. Install both on the HTTP server, inform HTTP server, enable the SSL module, create a specific port number for SSL, which is by default, it's 443. And then HTTP will understand this key file and start sending out the public key every time someone asks for anything. Very simple and straightforward, right? But what is the problems of it? Well, if you have 10 websites, you need to have 20 files because you have to create 10 of the private keys and 10 of public key. So it's not so good in managing multiple websites. So the alternative over here is your key files. Key files are basically a key database. A file which may contain multiple keys, and each key will be differentiated based on the alias name or label name. Remember this, there are two terms called alias name and label name. Some people or some tools calls it alias name. Some tools call it label name. Like for example, P12 KDBs call it label name. And JKS and Oracle will call alias name. So likewise, you have different vendors calling different names. But then it all works with the same logic as I told you earlier. So create a private key through which you take the route, which one you want to go for, self-sign or third-party sign. The commands to take these routes may be different based on the tools which you're using. You have KDB, that is CMS formatting. And then you have JKS, Java KeyStore, KDB is key database. And then you have P12, which is PKCS from IBM. And then you have Oracle Wallet, which is used for Oracle HTTP server and Oracle database. So these are the different formats available for you to use. And then you have this concept of key stores and trust stores and trust stores. Now, what is key stores and what is trust stores? Let's just talk about that separately. Key stores basically has private keys. Trust store has the public key. So why someone needs to have a public key only is because, for example, the first place I'm gonna show you public key is your desktop, your laptop. Okay, like trust store. Now, as I told you on the previous video about the server sends out the public certificate or public key to the laptop, right? And the laptop validates. Now, how it validates is that it goes through this something called OpenMMC. It's a Microsoft Management Console, and inside that, just go to File, add or remove snap-in, and then select certificates from here, and then click on Add, and then just finish. Click on OK. And you see that over here, these are the certificates or the trust stores I was talking about. So in Linux, it will be in a command line way where we execute commands to view those trust stores in a certificate. But in terms of Windows, it's in a GUI format using, we have to open it through MMC. Now here, what you want to see is that there are two types of trusted certificates. Okay, one is the root certificate, or I should say chain of certificates. A root certificate and an intermediate certificate. There are these two are the two types of certificates. So what is a root certificate? So under the root certificate, there's a folder called certificates. Root certificates are the top of the chain. So if I go in over here, let's just open this one. Connection is secure, certificate validity details. Now you see that if I just close this umbrella, the tree structure, you see this one, right? So this is called the root certificate. Now root certificate is Baltimore Cyber Trust. Okay, so this is a company who actually issues the certificate. So this company would have been established for a very long time and had a very very detailed career in certificate management. That's the reason why they are here. Likewise, there are other parties like these guys. Like, for example, I just tell you some of the names over here. You have Baltimore, which you just saw. The same thing expires on 05/2025. The same certificate validity should be 5/2025 or 12. So that's basically the same certificate which is over here. And then you have, you have other people like DigiCert, Entrust, Global Sign, GoDaddy. GoDaddy is a new one. And then you have Microsoft. And then Google also came up with this item. So I don't find it Google here. But then these are some of the known people, very signed. So these are some of the known people who actually signed certificate. So these people, if you see their expiry date, right? So the root certificate mostly issued for more than, for close to 20 years. So if you see this one expires at 2028, this one expires at 2038. So likewise, you will have a very large amount of period because the personal certificates periods are very less. Okay, and you won't find any personal certificates here because you cannot trust a personal certificate because it expires every 6 months to 1 year, and if you have to keep on adding them, and it becomes much overhead for older systems. Again, the same browser related problem is coming. Older systems without an update, right? They will not be able to browse any website if they are not trusting. So there will be an error coming in saying that this website is not trusted. It's not trusted because your certificates on your trust store on your system is not updated with the latest information or latest update. So this is the problem which you may find while accessing this. So this is basically your intermediate certificate. So you have the list of intermediate certificates over here. So if you're gonna go over here and you see that mostly it's the repeated name. So you have Microsoft, DigiCert, Komodo. Likewise, you have other intermediate certificates, but then major items is on the root CA. You can see a lot of certificates are there in the root CA. So this is Cloudflare the intermediate certificate, and then your actual website name, which is diagram.net. So you don't worry about the viewer.diagram.net because the SAN name covers a new concept called SAN name. SAN name is subject alternative name. So you will see subject alternative name over here. So now what they're doing is, like, instead of adding this viewer like picture.diagram.com, mail.diagram.com, diagram.net, sorry, they will add all these in the SAN name, certificate subject alternative name. So they give a wildcard over here. So you see a star over here. So this basically means that everything, including viewer and anything else. So they just add a subject alternative name over here. All right. So I'll tell you how to do that as well as part of your certificate, where you can add your certificate subject alternative name. So, and then basically That's the certificate I was talking to you about. So if you see that, we will talk in more detail about this certificate in the next video, but I don't want to push every detail in one single video. But pretty much, I want to tell you that the Trust Store has all the public certificate, like what you saw over here. There is also a very popular Trust Store called CA Certs. Now, this is the Java Trust Store called CA Certs. CA Certs is nothing but Certificate Authority certificates. So this is again a Trust Store which is by default comes with Java installation. So any Java you download and install, it's going to have its own CA Trust. So that's the first reason for having a Trust Store, and you know what is inside this Trust Store. What is inside the KeyStore? KeyStores are going to have multiple keys. So like, for example, you're configuring 10 websites. You don't have to have 10 key databases. You can have only one key database, and inside that you will have a last name or label name separating from each one. And then when your application calls for that particular key, it will use that last name to identify the unique key from there, and then it will call that key. So with the key store, it will also can generate from the key store. You can generate a public certificate. Remember, every time customer pings you, the duty of your JBoss is to respond with the new certificate, new public certificate, and the public certificate expiry wouldn't change, or the coding or basic requirement of a public certificate wouldn't change, but then generates it and then sends it to the browser who it's asking for. The browser then looks at the certificate, looks at the chain of certificates, see if any one of them are or valid or accepted, or it's part of the Trust Store. If it's part of the Trust Store, it's going to let you browse without any error. If it's not part of the Trust Store, or if it's not part of the Trust Store, or the common name is not matching the name of the website, or the SAN names. Okay, you have to check the SAN name as well if this is coming under the SAN name. So we saw that it's coming under the SAN name. So that's very important for you. And then they also check your system date should be in between these two dates. If it's either after or before that, also this is not a valid certificate. Though it is your computer problem, but still, according to the computer, it's still not valid. So this is the second thing it looks out for. So first thing is basically the third thing it looks out for. So the first thing is basically your chain certificate, see if it's part of the Trust Store. Second, if the common name is matching, including the SAN name, and the validity period of the certificate and whatever is in between that. So pretty much that is what is looked at this moment. So you can see that public key value, certificate key value, and then SHA-256 footprint. So basically this is your algorithm over here, encryption algorithm, your cipher value. So likewise, basically it will give you all the details over here, but these are values which you will not, you want to provide it to anyone in the world to understand it, but this is not something to do with your private key value. Okay, so this is just a generic information which everyone can understand and access. Now, a key store can be a Trust Store as well. Yes, so you can add a public key and private keys on the same file, unless and until that file is not shared with anyone. Okay, so no one should have access to the private key. So normally people separate it so that they don't get confused and share it over the email or anything like that should happen. So that's why they normally separate both these things as separate. But sometimes they put it together as well. All right. So I hope that you understood something about the SSL internal configurations and the routes you're going to take in this video. I'll see you on the next one.